Okay, the next one, for 14, 18, and 21, to find the LCM, instead of listing down everything, which might be what we would have done in primary school, we're now going to use our method that we've just done, 14, 18, and 21. So draw this. What is the lowest common prime factor that we can see? Is there any? 14, 18, and 21. Is there any? No, right? We don't have 2, 3, 5, 7, don't have anything. But here's the other thing that you need to take note, and we're going to use this example to show us how we can still use this method. As long as any two numbers have a common prime factor, we can continue. Okay, what do I mean by that? Is there any two numbers with a common prime factor of 2? 14 and 18. So let us put a 2 over here, and we're left with 7 and 9. Then your question should be, what should I do with 21? Right? We just copy it down. Okay, so this is the difference. This is another difference that we have. Copy it down. Let us continue. So the rule is, as long as two numbers have a common prime factor, we can continue with this method. So can I still have a factor 2 within these three numbers? Factor 2? Don't have. The next one is 3. So let us put down 3 over here. First number is 7. Is that a factor 3? No. What should I do with it? What should I do with the 7? Copy it down. So 9 divided by 3 is 3. 21 divided by 3 is 7. Are there any more common factors? 7, yeah. So we put a 7 over here. We're left with 1, 3, and 1. Are there any more common prime factors? Don't have already. Prime, So you cannot tell me 1 is a common factor because I said prime. The smallest prime number is 2. So we stop here and we say that the LCM is now equals to all of these multiplied together. Okay, how many 2's are there? Only one of it. How many 3's are there? So times 3 squared. How many 7's are there? 1. So multiply by 7 and our calculator will tell us this is 126. You may be unfamiliar with this method, but practice and you can get it. Alternatively, you can use index notation, which is what I first taught you. Okay, line all of them up in very neat rows, and we just copy down whatever was found in all of these for both or three of these numbers. Just copy them down only. Personally, I prefer that method. Okay, so it is time now to tackle some questions. Exercise number 10. Okay, so please flip to it. We've got two numbers A and B. A, in index notation, looks like this. B looks like this. Do you think you should evaluate it? Should we take our calculator and find out exactly what is A and what is B? No, there is no reason to. In fact, we want to leave it like this so that we can solve for part A, B, and C quite easily. Alright, so now I want the largest integer, which is a factor of both A and B. Take some time, understand the question. What do they want you to find? For part A, the largest integer, integers are whole numbers, 1, 2, negative numbers also. Okay, so negative 900, negative 1000, negative 1, negative 2. All the way until positive numbers, 1, 2, 3, 4, 5, 7, and 10. Whole numbers, and it includes 0 also. Okay, we'll talk more about integers along the way. Basically, when you see the word integer, it just means a whole number. Cannot be fraction, cannot be decimal. That's it. Find the largest number, which is a factor of both A and B. A and B are quite large numbers. I want the largest factor for both of them. What am I trying to find? Is it HCF or LCM? HCF or LCM? A common factor for both A and B. It must be HCF. Okay? So now we are ready to write down. Sometimes I like to copy down the questions because it helps me to understand. Then 2 cubed times 3, then the next one I should write is 7. But I prefer to leave a blank space in case the next number has a 5, which in this case don't have. So it's fine, we just leave a little blank over there. B is 2 power 2 times 3 power 4. And now I want to find the HCF. I find this presentation quite neat and I encourage you to use it. So for HCF, we are trying to find all the common factors that we have. Now looking at the prime factor of 2, how many of them are common? 2 of them. So you got 2 squared. Looking at the prime factor of 3, how many of them are common? Only 1. And so our HCF will be 4 times 3, which is 12. That is the answer for part A. Ken? Any questions? Then let us move on to part B. Yeah, for part B, lowest common multiple. Okay, it's quite clear in the question already. For part B, I need a lowest common multiple. And I show you the beauty of using this presentation. I can do it, but you cannot because I'm using a tablet. Okay, so I use the same presentation, but now I change the HCF to LCM equals to. Okay, for you, you will need to rewrite your A and B again, unless you have some other way of doing it very neatly. Okay? Now, for LCM, the difference is that I'm very greedy. I want to take everything in. So for the prime factor of 2, what is the one with the higher power? 2 or 3? 3. Copy down 3. For the prime factor of 3, what is the higher power? 4. And the next one, 7. The higher power is 1. Over here, we've got nothing. So we bring down the 7, and we've got 7. And using our calculator, we get an LCM of 4,536. So using this method has many advantages compared to whatever we have learned previously. Okay? Part B is LCM already. Part A was HCM. Okay, at this point in time, I will pause the recording. This is actually A times N equals to LCM of A and B. Okay? Or anybody unsure about this part still? A times N is actually LCM of A and B. And now I'm going to replace the LCM of A and B with whatever we found in part B, which is 2 to the power of 3 times 3 to the power of 4 times 7. All okay so far? Alright? Now I'm going to replace our A, because A is the same as 2 cubed times 3 times 7. I'm going to copy it down so that it's easier for us to see. Okay? So that it's easier for us to compare. So part C over here, A is actually 2 cubed times 3 times 7. Now can you tell me what is N? 2 cubed times 3 times 7 times an unknown over there will result in 2 cubed times 3 power 4 times 7. What must N be? 3 times 3 times 3, which is? What is the value? 27. Okay, so based on this, we know that N, or this arrow over here, also means therefore. It must be 2 dashes and then 1 arrow like this. Therefore. Okay, so based on our working, therefore, we know that N must be equal to 3 to the power of 3, which is 27. Now, knowing how to do this is one thing. Making sure you don't have careless mistakes is another thing. How many of you think that 3 cubed is actually 9? How many of you actually could think that 3 cubed is 9? I know I would have made that error when I was a student. Okay, so you need to be very familiar with all these things. 3 cubed is 3 times 3 times 3. 9 times 3, 27. Alright? Be very careful of all these things. Alright, next one, question 11. Exercise number 11. Can you try part A by yourself first? We got another 5 minutes till the bell goes. Can I check how many of you have a presentation that looks like this? For part A, you write down A equals to 2 square times 3 square times 5. Be generous with the spacing. For B, 2 square times 3 cubed. Largest integer, which is a factor, means HCF. And then you copy down whatever is common. 2 square times 3 square. Our answer is 4 times 9, 36. Do you have this as your presentation? If you have, then very good. If you don't, then you have to let me check your presentation to see whether it is acceptable or not. Now for part B, this is for A. Now for part B, we want to find the LCM. So we use the same presentation, but we remove HCF, we change it to LCM. Copy down the higher power, in this case it is 2. The higher power is 3 cubed, and we multiply by 5, leaving us with 540. Understanding again. 2 squared times 3 squared times 5 times n. So I'm literally copying down all this. It's supposed to be LCM of A and B. Okay? And the LCM of A and B happens to be found in part B. You can choose to write down 540, or you can choose to write down the index notation. Which one is more useful? Yeah, index notation, because it allows us to compare really quickly. 2 squared times 3 cubed times 5. You have to be very careful with the word difference. Because when you say difference in mathematics, it means minus, right? Well, it is not exactly minus over here. We look at how they are different. Okay, another way of saying, how are they different? What do I need to multiply to this? In other words, what is the value of n that makes the left hand side the same as the right hand side? Okay, so the answer must be 3. N must be equal to 3. When n is equal to 3, our 3 squared will become 3 cubed, and everything else stays the same. And that is how we get n equals to 3. Okay, this is a problem sum that you can do as your homework also. Bring back on Tuesday, because we don't have lesson on Friday and Monday. Okay, so try this. I will now do one last question, exercise number 12. Bread rolls are sold in packs of 48. Wow, very big packet of bread roll, 48 of them. And chocolate bars, even more exaggerated, 150 in a packet. So he buys the same number of bread rolls and chocolate bars. We are not saying that he buys the same number of packets. We are saying he buys, I don't know how many packets, but he ended up having the same number of bread roll and the same number of chocolate rolls or chocolate bars. So find the least number of packs that he could have bought. Is this a HCF or LCM question? Good, it is an LCM question. And to find the LCM of 48 and 150, you have two methods that you have learned. My preference is using index notation. So for that, I'll need to do this first. So practice doing it quickly. 6, 2, 3, 3, 1. So 48 is 2 to the power of 3 per 4 times 3. Okay, and the next one, sorry, just give me a little while more. Here we've got 150, 2, 75, 3, 25, 5, 5, 5, 1. So 150 is actually 2 times 3 times 5 squared. Draw a line, LCM. We are being greedy when we find LCM. What is the power of 2? Based on my prime factorization, what is the power of 2 over here? Take the higher power. What is the higher power? 4, okay. What is the higher power for 3? It is 1. Power 1 over here, power 1 over here. Okay? And the last one, 5 squared. This is my LCM. And I can calculate it out to become 1,200. In other words, he bought exactly 1,200 bread rolls. He bought exactly 1,200 chocolate bars. Is the question answered already? Is the question answered already? Is 1,200 the correct answer? No. at this point in time, you haven't found the correct answer yet. Okay? So, yeah, list number of packet. They want packet. They want a number. So we need to find number of packets. Y divided by 2? No. Chocolate bars. Divide by 150. Okay, he bought 1,200 chocolate bars, all of which one packet has 150. So this leaves us with an answer of 8. Alright, I hope the presentation is neat enough for you.